So yeah, so you may have some questions about the test. Let's start with that. The solutions should be appearing shortly. Well, maybe not. I haven't plugged in yet. Yeah, any questions? I mean, I can go through these kind of fast. This one, if I could scroll on this, it might help. This one is several people only just provide a single set of dashes. You need two. So yeah, you need those two there. The method to return the first n characters would look something like this. A couple alternatives there. There were some more that I didn't include, but so this is you know, returning the substring of s from 0 to n if n is less than the length. Otherwise, just return the whole s. And some people did do a concatenation of a bunch of chars. The combination lock program was a chance to see how well you can read these things. Got to be careful. There's always little tricks involved. So we make a new combination lock. And that uses the default constructor, and you can kind of see that's making an integer array and setting the lock open to true. What are the default values in that array of integers? Should all be zeros, right? And the lock is defaulting to open. That's the status indicator. And then we set the combination to this. And set combination says if the lock is open, it can actually do that by assigning these values to the array. And then we lock it. And then we change our mind and decide to set the combination to 10, 12, 19. But if you go back up to that method and you try to do that, you realize, oh, but lock open is now false. So all you do is you print out the lock must be open to set. And you don't actually change the combination. That's the tricky thing there, right? You have to be able to kind of follow that. And since the combination is not set, when you try to unlock it with this combination, it's going to go up to the unlock method. And it's not going to be correct. So it is going to say return lock open is going to say false because this is not actually a match. And then it will print out sorry. So that is the expected output for that, right? So when it goes into here and the combination doesn't match, this is deciding whether the lock open is going to it's going to be open or not. It's only going to be open if there's a match between the different parts of the combination and the thing that the people entered. So Questions on that? Let's see. Then an explicit constructor. This one is, you really have to be careful. A lot of people got kind of sloppy here because they thought the explicit constructor, no, actually this is okay. Yeah, we're making a bike lock and setting it to these values, and true means it's initially unlocked. And so some people, you have to realize when you construct things, you don't have to follow the same rules of whether the lock is open or not. So some people didn't want to set the combination unless it was open, unless they had true here. But basically the idea is you have to copy the lock open variable to the instance variable, and then you have to initialize the combination array with a new array of integers. A lot of people forgot to do that. And then you set the different fields to A, B, and C of that. That would be what the constructor looks like. The toString method would, here's where people had a print like bike lock. You're not making a toString method that prints bike lock because that would always restrict you to having a bike lock only, where this is a lock that could be any kind of lock. So the bike lock is in the print statement of this, continuing the example here where we created a bike variable of type combination lock. And we then print it out. Well, this automatically, of course, invokes the toString method without us having to say that. That's one of the nice features of toString. So we activate toString on bike, and all it should print out is open, because the bike lock is open. This is just coming in the print statement that we're using to print out the value. So the toString method just returns open or closed depending on the value of the status of the lock open. So if it's true, you return open. If it's false, you return closed. It should return a string. This is not actually needing to print out anything. The toString method doesn't print out anything. It just returns the string so that it can be printed in a print statement that's elsewhere in the program. And you've got this one, which is sort of doing a shift. We have an array. So this is one where you would want to do a trace. And you plug in here when I is 1, it's going to be location 1. Location 0 gets the value at location 1, right? And when I is 2, this is location 1, gets the value at location 2. 2 gets 3, and 3 gets 4. So that means we're copying this 0 over here into the new array. And this 1 comes over here, this 0 comes over here, and this 1 comes here, and the original 1 in location 4 stays there. So the result should be 0, 1, 0, 1, 1. Any questions so far? This one is, it has a loop that keeps removing kiwi as long as kiwi is still in there. So that's going to just leave axe and forge in there, whatever order you have is fine. This one is, I don't know, a lot of people thought a lot about this and decided that maybe they didn't realize the remove method without an argument was there. So the remove method just removes any old item, which is what I sort of meant. Remove an item from the bag. So you can make a variable to hold on to it. And then if the bag does not contain any instance of that same item that was removed, then put the item you removed back in the bag. So if it doesn't contain that item that you removed, then add it back in there. Okay, questions? The stack one is, really some people were, this was an example where, if some people who got the wrong answer, if they actually showed me their work, they didn't lose too many points because I could see their logic. If you just had the wrong answer but didn't tell me how you got it, then I don't really know what your thinking was. So you should get into the habit of trying to sketch out your thought process of the test. If you're not doing that already, it's really good. This one is doing CB and then multiplied together, and then it's dividing by A. So this one's sort of doing C times B divided by A, and then E minus is just doing a minus E. Whereas the other one is doing B minus A first, and then adding C to that, and then doing a multiplication with D. So it's 5 times 4 plus 3 minus 2. That's what's being calculated. The linked node problem, again, if you had a good sketch, that would really help. Knowing how to make a sketch of that would be really good. So you have these 3 nodes with an A, B, and C in it, P1, P2, P3. You're rearranging things. P1 next equals P3. So that's making the A node point to the C node. P3 next is pointing to P2, which is the B node, and P2 next is pointing to P1. So it's kind of a circularly arranged list, printing out the data and the next data. So that's going to give you a C, P2 data. P2 next data is going to give you BA. And this one keeps going around all the way. So we start at basically at P2, and then we go to the next, which takes us to P1. And then we go to the next, which takes us to P3. And then we go next yet again, which takes us right back to P2. So we just print out the data at the place we started. So that's kind of going full circle around that loop. Okay, questions? The Q one is asking us to write a loop that moves everyone in the front until Jim is at the front. So, and we put them in the back. So as long as the front doesn't equal Jim, then we're going to enqueue the result of a dequeue operation. There's other ways you could have done that, but that's a straightforward way. Antonio, is this the one you had a question on? Okay. 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 You want me to take a look? And then number 11, showing what's printed by the list. This one actually threw a lot of people. Again, a trace is really helpful, right? And knowing how the add method works, when you say add 1, 2, it doesn't mean you're adding 1 and 2 to the list. It means you're adding a 2 at position 1. And you can find that in the UML diagram that was provided. So that's showing you here. This is the method here that takes 2 items. The first one is the position, and the second one is the value. So you convert all these k's into actual numbers, and then you can construct the list. First, we're adding the 2 at position 1. Then the 3 at position 1 makes the 2 move over 1. And then the 2 at position, the 4 at position 2 is actually inserting the 2 in between the 3, 4 in between the 3 and the 2. And then the 5 at position 2 is inserting the 5 in between the 3 and the 4. So it's kind of building it out that way. As you continue, you'll end up with 3, 5, 7, 6, 4, 2. Okay. Questions? Anybody have any questions? Okay. Well, I'll look at your code, Antonio, after we kind of start the lab then. Pretty good. We have 3 people who didn't take it, so the average. The average was 81 with 3 people, including zeros for 3 people in there. So it's pretty good average. It's a question of, you know, a lot of it is kind of a precision. Can you actually read the code carefully and kind of follow it along? These are really important skills to be able to read and write code. Some people, I guess, might prefer to have a compiler to kind of tell them when things are going on, but this is it's just much easier for me to read this way when it's on paper. So you made it to the second module, the second segment of the class, which is where we're going to start building the data structures. We're going to start by building an ArrayBag today. That's the and you can grab the download here. So we've had a lot of preparation, and in today's lab, you are going to learn and apply your understanding to build a bag class, and you're going to run it through all these test routines and try them out. So all of your pretty much all of your work is going to be in the ArrayBag class, which is currently just defined as a bunch of skeleton methods that you're going to fill in. And it's quite a few methods. Some of them are easier than others. Some of them are going to be somewhat familiar, like there's a remove method that it's not the same, but it's sort of like what we did with the removing an item from an array. And some additional methods, which we're going to kind of explore here in the lecture. So I'm going to do a kind of a quick rundown of what you're going to be doing in this lab. And we're going to be looking at some of the interesting design choices you can make when you're making a bag. You've been using a bag now for a while. You just had to write some code involving a bag. How does a bag actually work internally? You should have some idea, just having worked with a bag, kind of how it actually is all sort of taken care of. But we're going to, today you're really going to learn how a bag works, because you're going to build one. You're going to be able to resize the array. I think, are we resizing? I think we have a resize option. I can't remember. And we'll be looking at some of the pros and cons of using an array. Actually, I think we're going to do a fixed size array today, and then the list that we're going to do on Wednesday, I think, is going to be resizable. With the idea of a fixed size array for the bag, you can imagine that you have a classroom with something like 40 desks numbered from 0 to 39, and the idea is that that sort of symbolizes your array. The desks are places where students can actually seat, and when you add somebody to the room, they're going to be added starting at 0 to the next chair available. When you remove someone, you can sort of think about how you might remove somebody from the room so that you don't have any gaps in your data. So the idea of removing a student is, you have this option of, in this case, you would maybe, if you remove the item at the second location in the array, then you have to slide everything over one. There's actually two options here. This is kind of interesting. Before you actually dive into this, you kind of think about these things. So in this case, you have to make a loop that moves the items over one, kind of like that problem that you solved in the array lab. But this one's actually a little more clever. What's happening here? The one on the right. Yeah, what you could do is, you still have to remove Alice. Alice is going to go away, but you could take the last person and move them to the location where Alice was. And then you have a completely full array, and then you can essentially delete the item at the end there, so you have just that one deletion. Which one is going to work faster? The second one, right? There's a lot less work involved, especially if the bag gets really large, right? This is an example of they call big O, or order of magnitude, how long it sort of takes as the size of the bag grows. This is sort of O of n, meaning it's going to take on average approximately n operations, where n is the size of the bag, to do a remove operation if you're going to use this algorithm. Where this one's called O of 1, in other words, it's going to be constant time to do the removal no matter how big the bag gets. It's just moving an item from one place to another, constant time. And this has an advantage, and we're going to sort of focus on that later after we do these example data structures. But why do we want to actually make sure there's no vacancies anyway? Why don't we just leave a null in our bag in the middle of the array? Yeah, your code would have to have a lot of safety checks to make sure that the reference doesn't have a null in there, which would maybe mess up your your operations, give you an exception. And is there an advantage of just leaving the vacated desk vacant? Less bookkeeping, I guess, to kind of move things around. I mean, if you had to do this, that would be sort of annoying. Maybe you could just leave it vacant. I don't think it's too much of an advantage. If a student were to drop the course, which one could do so without forcing anyone to change desks? Yeah, the last person in the array could drop without doing anything. Right? Yeah. So if the students remain in consecutive number of desks, you don't have to keep track of the location of the gaps, which is nice. So yeah, so that's the kind of the thought process that goes into designing these things. This is the UML diagram, which indicates the kind of methods we'll be writing. And there's sort of the, basically how you define these is kind of important. You don't want to sit down and actually write out the entire bag class, all the methods, and then start testing it. Why is that a bad idea? It's really hard to find the errors when you do have them, and you know you're going to have errors. And also, you might have made a mistake, like in your general framework of how you're thinking about it, where you have to you might have to throw everything you wrote out to actually start over again once you realize the problem that you start finding it. So basically, the way coders work is that we tend to not like to write too much code before we do some kind of test on it. You should at least compile it and then run it with some test cases. So that's why the program that you're given has a lot of those problems where you're just going to do like 2 or 3 different methods, try them out, see if they're working properly. And by the way, you really have to read the output to make sure that your code is working properly. It's quite possible that if you skip something, if you don't notice there's an error, at some point later on, you're going to find another error taking place. And it may not be in the code that you just wrote. It may be in something that you wrote in a previous problem if you haven't been checking your errors carefully. So be really careful about looking at your results to make sure that it's showing what it's supposed to show. And don't continue until you do have it working right. So we define test and then continue with the rest of the class working incrementally. There are a lot of decisions you need to make when a bag is partially full. Which elements should contain entries? Should we start at element 0 or element 1? You know, like the list class, or require the elements to be sequential? Those are a lot of design decisions, right? So here's an example of some pictures you can draw. It's always really good to sort of sketch out how you want this thing to look. If your array is empty and the number of entries is sort of keeping track of how many items are in the array, when you add Doug to it, you can see that Doug is being added at the location of the number of entries, and then we add 1 to the number of entries to indicate that we have 1 item. This is kind of helpful, right? Because number of entries is sort of telling you the location of where the next item would be added, right? So when we add Nancy, we're going to add Nancy at the location where the current number of items is, and then add 1 to that. And add Ted at the next location indicated by number of items, and add 1 to that. And we keep building the array as it grows to the right. The solution to all of the methods, I think, are in these PowerPoint slides. So if you're really stuck, you could just kind of follow along in these slides. But you should try to do these on your own, because you want to learn how to actually do this kind of operations independently. This is the kind of stuff you'll have to do. On a test, you'll have to write some methods involving bags or lists or something. You're going to have to figure all that stuff out. This is sort of the goal of the class, is for you to learn how to do these things. A convenient way to think about an array of objects is where the data is stored inside the array. That kind of is helpful for sort of simple. But of course, the way they're really stored is something like this. And it can be helpful sometimes to, this is more of a shorthand notation, but ultimately it's good to know that this is the real, true way the data is being stored, where the array is only holding references to the objects, not the actual data of the object. So that can be helpful, and a lot of the diagrams we write are going to reflect that. So if I was going to draw a memory map of the ArrayBag object, I would start by, by defining this variable ABag. And what is ABag? It's a reference to a bag object, right? And what does the bag object have inside it? What? Strings. Okay, strings, yeah, but more specifically, like, what are the instance variables for the ArrayBag? And you can kind of see here in the UML diagram, what are the instance variables that we're using for the ArrayBag? They're up at the top here. What are these? An integer indicating what? The number of entries that you've got in the bag, right? And then what else is in there? Capacity of the bag, which is a constant, right? That's not a variable. That's just going to be like 25 or something. Standard bag can only hold 25 items. But what's this thing on top? It's an array of type. Good question, right? Objects. We're going to start off by making them an array of objects, but this T is a generic placeholder for that specifier. When you make a bag of string, what does T equal? T is string, and so you're going to have like a string array in there, right? When you make a bag of items, T is going to be items. Okay, and that's helping us with the checking to make sure we don't add something to the bag that we're not supposed to. You remember how that works. When you make a bag of string, you're not supposed to be able to add an array of string to the bag, right? It should give you an error when you try to do that. But initially, we're going to make our arrays of just objects so that you could add anything you want. And then later, you're going to fix that to make it just work with the generic type specifier. And there's instructions on how to do that in the lab. So what are the two things? We're going to have a number of entries. Which is an integer, which is initially 0, right? Can you read that? That's terrible writing. My writing is as bad as some of your writing. And then I don't really like this. I don't really like calling it bag, the array called bag. It should be called like, my array or something. I think I'm going to change the names of these things when we do the lab, if you follow along. And bag is a reference to the array, which is stored somewhere else. So if we add peas to it, that's a string. We're going to have an object called peas here. If we add tofu, tofu is going to be stuck in the next one. Carrots and celery, all that is done in order. Let's do that this way. And then we say remove tofu, what happens? This is kind of a good question. What happens to the bag when we say remove tofu? How does the memory change? Well, it depends on which way you want to do the remove operation, right? If you remove the second way, right, what's going to happen? When you want to remove tofu, what's going to happen to the celery is going to move to where tofu is, right? Yeah, you're going to copy the reference to celery over here. And well, before you do that, you're going to basically, well, by doing that, you're clobbering your link to tofu, but you're going to have a save it so you can return that tofu as the return value from this method. So the remove method should return a reference to the object that you're removing so that you can do something. Here's the isFull method. That's just checking to see if the number of entries is the same as the size of the array. And you don't have to have any if statements when you do that. You notice there's an equality operator there. That's either true or false. So you don't have to say if number of entries equals bag.length, return true, else return false. You can just say return number of entries equals bag.length. A little bit of a shortcut, shows you know what you're doing. The toArray method is interesting. There's all these, we're going to talk about this, there's all these interesting things here to suppress warnings. I'll explain what that means later. But here we're trying to create an array of type T, which is the type of this thing. Actually, there's sort of a mistake here in the slide. This should actually be an object array, not an array of type T. That has implications. So I'll explain that, I think, as we do the beginning, we do the constructor together. But what it's doing is it's making a new array and copying all the items over into the new array and then returning that as a way of just giving you the contents of the bag. Okay. In the previous method, does the value number of entries equal the bag.length in general? Oh, it's interesting that they're making the array size by equal to the number of entries. Does the number of entries equal the length of the bag in general? So why don't we make this say bag.length here instead of number of entries? Wouldn't it be more correct to say it should be bag.length? Why should we why should we say number of entries there? What's the consequence of that? Yeah, if you've only got one item in your bag, and the bag can hold like 1,000 items, do you really want to return an array of size 1,000 when only the first item is going to be non-null, right? Everything else is going to be null in it, right? If you do that, right? So, so you want to actually just return an array that's sized basically on how big the bag's currently, how many items the bag currently holds. So that's why I put number of entries in. What else is good? I think that we can skip over some of these things. There's some interesting stuff, but what about the toArray? Should it return the array bag or a copy? Why is it returning this guy is making a copy of the array. Why would we want to make a copy of the array? Why don't we just return bag? That would be an array that has all the items. Marco? Could be because arrays are fixed size? No, that's I mean, it's a good thought, but what would be the issue if we returned bag itself? Can you imagine something that might go wrong if you do that? returning a reference to the array itself, returning bag. What would happen? What could happen? What could possibly go wrong if you do that? Anyone have any ideas? Would it return the address? Well, yeah, it's returning the either way, it's returning the address. Here it's returning the address of the results array. But if you made this say bag, returning the address of the bag array, what would be the consequence of that? Sorry? Yeah, suppose the user makes some changes to the result array. If they had access to the bag array, you could start deleting some of the items in the bag outside of the bag class. You know what I'm saying? So if somebody makes an array version of all the data in the bag, then they could actually, they've got the contents of the bag. They can really screw up your bag itself, right? So it's safer to give a copy of your data to the user that's requesting it, right? This method is giving outside access to all the contents of the bag, right? So if you don't give them a copy, then they could, you know, have access to the guts of your bag, and that would be kind of dangerous. Yeah, so something like this. Suppose you're actually getting the contents of the bag into this bag array variable, and you set bag array of 0 equal to null. That would be bad, right? You would be wiping out the first item to screw up all the rest of the code. This is something that, like, you know, hackers or somebody who might be trying to exploit your code might try to do. So you know, sometimes you need to make sure you keep all those opportunities for messing around with your code kind of closed. Let's see. There's a little about the isEmpty method, the get current size, get frequency of is counting how many, contains is checking to see if something is in there. Like I said, you can look at those if you want. These are the methods that remove an entry. It's a good idea for you to, like I said, try it without looking at the answers, but if you need to, then you can check them out. These are the two options for removing a specified entry. First, locate where it is. Then you can shift over everything or just move the last item into the gap. One thing we don't do is they define some auxiliary methods, which I don't recommend us doing. I think it's better just to do it all in that method. But you can make a get index of method, which then, you know, finds the location of where something is, which can be used by other methods. I think it's just good practice just to kind of create these methods. Notice this is a private method that would actually only be accessed by other members of the class. Resizing an array, we're going to look at that, I think, on Wednesday. But if your bag runs out of room, you could decide to just resize it. In that case, you got to declare an array that's twice as big and then copy over all the items, kind of like what you did in the original example, in the original array lab. Alicia? It's not that you give the person a chance to resize the bag. It's just that the bag would automatically resize itself. Whenever we run out of room and somebody adds another item, the bag could just go off and get another larger chunk of memory, larger array, copy all the items from the old array into the new array, and then that becomes the new array for the bag. Yeah, so that holds all the data. There's a nifty method called arrays.copyOf. Did we play around with it? I think I showed you at one point and said you don't really need it yet, but this is where you could use it if you're doing a resize operation. But again, I don't think we're doing resize today. I think we're doing that on Wednesday. But the arrays.copyOf method is pretty nice because you can make a new array based on an old array. Check it out. Here's my array, right? And you want to make a new array that's twice as big as the original array, so you put 2 times my array.length in there, and then it automatically copies over all the items, the old array, the array, leaving you a bunch of zeros in the remainder of the array. So that saves you a lot of headache. Yeah, it's a very cool method. No, it's in the arrays class, which you have to import java.util.arrays. That has an S at the end of it. Make sure you put that S in there. And here's some examples. Just kind of skipping this. Then there's a if you want to make a resizable ArrayBag, you can do that. Yeah. Anyway, this is kind of going a little bit further than we need to. Some thoughts, though, of the design of this. When you're when you're using an array to represent a bag, adding an entry to the bag is going to be pretty fast. You're just going to add it to the end. Removing an unspecified entry is fast. You're just going to remove the last item from the array, like a stack. Removing a particular entry takes a little bit of time, and then increasing the size also takes time. And these are some of the pros and cons. When we look at linked structures, we're going to do that next week. You're going to have an alternative way of building those using linked nodes, and some of these things will have different speeds associated with them. Okay, that is the end of lecture. So let's get started on the lab. And let me make sure that everyone has a handout. So who needs a handout? Again, I did not see a lot of drawings on the linked nodes thing, and I just want to make sure people have that chance to practice doing a memory map, because this is something that you're going to want to do sometimes in a test to make sure that you understand. And typically, if you actually look through the lab, you'll see the way I've actually structured the lab. These are kind of crude ASCII sketches, but they're easy for me to actually indicate, to draw and modify. But you can kind of see that each of the methods, like the add method, is showing you kind of like a before and after drawing of the structure. And this is, you should really look at this and kind of study it, because it'll help you kind of figure out what the code is that you have to write. So when we want to, here's like the original, here's like the before. Here's an empty bag. If we add ball to it, we want it to look like this, where the my size, and I'm changing the name of these variables. The array is called my array, and the size, or the number of entries, is called my size. I do that to kind of distinguish the fact that we're writing this code for each instance of a bag. So calling it my array is like the instances array. My size is like the size of the instance that we're looking at. So it's like duffel bags array size, duffel bags array, duffel bag size. So after you add ball, it's going to look like this, and notice the size has gone to 1, and you have this thing there. After you execute another one, cap, the size looks like that, and the memory looks like that, right? So all these are, and these are helpful design steps, so that you can realize, well, when you want to add something to the bag, you've got to store a new entry at location my size, and you got to add one to my size. But then what if the bag is full? We have to add an if statement to, so that to check that it's not full, right? So the get frequency of method is telling you, given the bag that looks like this, if you call it get frequency of ball, it should say 3, because you got 3 balls in there. The contains method, something similar. Again, the remove method is showing you a before and an after. And ultimately, I expect you to be able to draw these things and to come up with your own examples before and after. If I ask you on a test to write a method that does something, you're going to do a lot better if you can come up with a specific example and then show a before and after. In fact, I think I split it because I think in the next test, there's definitely a problem where you actually have to, like, given a problem statement, you have to draw a before and an after of the bag or the list or whatever we're doing, coming up like with your own example cases, I think, so that I can see that you can actually, this is a really important problem-solving step to really understand how to do that. Then you can actually write the code, but it's a different problem for that. So it kind of separates those. So you just have to do one where you got to take a problem statement and draw the picture that goes with the problem. And so on. After you get to a certain point, you should be able to do those on your own. Then there's the part where you're going to make, after you do the basics with an array of objects, you're going to turn this into a generic class by changing object to T and then making the following, the changes listed. The toArray method is also kind of spelled out for you. And then after you get to problem 8, if you finish, you're basically done. We're going to pick up the array list class on Wednesday. Some people might want to work ahead, that's fine. But you only have to get to the end of problem 8, and then we're finished for today. If you're still working on, like, was homework 2 due on Sunday? I didn't check the dates. It was due, it's due on this coming Sunday? Oh, you still have another week. Okay, so if you're still working on homework 2, you pull that up. If you're having any problems, I can kind of come around and help people. So you might finish this relatively quickly, but if not, no problem. So what I want you to do, though, before you get started, is sketching out the bag that results from these operations. Again, really important that you can do this. So take a minute or two. I'm just going to let you work on your own. It should look something like this. Your bag should look kind of following that same sort of prototype, same diagramming sort of nature. You should figure out, you know, what does it look like after these operations have worked on it. Because if you can't draw a clear picture in memory of what you're trying to do, it's infinitely harder to actually write the code to do that. Right? Drawing the picture is a really, really important part of this. So go ahead and do that right now. I will come around and walk around if anybody has any questions, and then I'll kind of give you my take on what it should look like. That, right? So the question is, for the add method, because the add method is supposed to return true or false, as you know. And yeah, in red here, although it doesn't show up on your handout, these are the steps you're supposed to do. But if the bag is full, you should add an if statement. So that only do the above steps if the bag is not full. And you're supposed to return true if it was successful in adding and false otherwise. Yeah. Mm-hmm. Yep. So read the lab handout carefully. It's going to give you a bunch of steps to solve all these problems. You might have to read ahead a little bit if you just jump in, but each problem is pretty well defined. So those are my answers to the sketches. We add 4 items to bag 1 and then remove 2. A C before the E? I get a D. Did I do that right? No, wait. We add the D and remove it, right? Yeah, this should be a C, right? Yeah, because we got the C. We had a C and a D here, and we did a remove to get rid of the D, and then we did a remove to add that to bag 2. So that was removed from there. Sound good? Thank you.